Ever wondered how you can run multiple operating systems on a single hardware? The answer lies in virtualization. Let's start by defining what virtualization is. In simple terms, virtualization refers to the creation of a virtual version of something, whether it's a server, a storage device, a network, or even an operating system. It's like creating a digital twin of your physical resources, which can then be accessed, managed, and utilized from anywhere at any time. One of the key advantages of virtualization is cost savings. By running multiple virtual systems on a single piece of hardware, businesses can significantly reduce their expenditure on physical resources. It's about doing more with less, and in today's competitive business environment, that's a major advantage. Another benefit is improved productivity. With virtualization, you can quickly and easily spin up new environments, allowing for faster deployment of resources. This means that tasks that used to take days or weeks can now be completed in a matter of hours. Increased uptime is another significant advantage of virtualization. By creating redundant virtual environments, businesses can ensure that their operations continue uninterrupted, even in the event of a hardware failure. This could be the difference between a minor hiccup and a major catastrophe. But how does all this work? Well, that's where the hypervisor comes in. The hypervisor is a piece of software that creates and manages virtual machines. It allocates physical resources such as CPU, memory, and storage to these virtual machines and ensures that they do not interfere with each other. It's like the conductor of an orchestra, making sure that all the parts work together harmoniously. Whether it's isolating applications, running multiple operating systems, or creating entire virtual networks, the hypervisor makes it all possible. So, essentially, virtualization is the act of creating a virtual version of something, including but not limited to a virtual computer hardware platform, operating system, storage device, or network resources. Did you know there are different types of virtualization? Let's dive into the vibrant world of virtualization and explore its various types. Firstly, we have server virtualization. This is the process of creating multiple isolated virtual environments on a single physical server. It's like having several unique computers operating on one machine. The main benefit here is the efficient use of resources. You can run multiple applications and operating systems independently on a single server, saving you both space and money. Next up is network virtualization. This is where the magic happens in the world of networking. It's about creating a simulated programmable network that can be managed independently from the underlying physical network. Imagine being able to control your entire network, divide it into segments, and assign resources without worrying about the physical aspects. It brings flexibility, speed, and scalability to your network operations. Then we have storage virtualization. This type of virtualization is all about pooling physical storage from multiple network storage devices into what appears to the user as a single storage device. It's like having a large storage closet, where you can store and retrieve data without worrying about where exactly it resides. It simplifies storage management and improves scalability. Lastly, there's application virtualization. This involves abstracting the application layer away from the operating system. Picture running an application on your device without actually installing it. This enhances mobility, reduces compatibility issues, and makes software management much simpler. Each type of virtualization has its unique uses and benefits. Server virtualization maximizes resource utilization. Network virtualization enables flexible and efficient network management. Storage virtualization simplifies data storage and retrieval, and application virtualization makes software deployment a breeze. As you can see, virtualization is not a one-size-fits-all concept. It's a dynamic, versatile tool that can be tailored to suit a variety of needs. Whether you're managing networks, servers, storage, or applications, there's a type of virtualization that can make your job easier. Knowing the types of virtualization allows you to choose what suits your needs best. So, equip yourself with this knowledge and harness the power of virtualization to your advantage. Now, can you imagine the internet without addresses? It's like a city without street names. Welcome to the world of IPv6 addressing. In this vast digital universe, every device needs a unique identifier, a way to say, "Hey, I'm here." That's where Internet Protocol version 6 or IPv6 comes into play. The successor to IPv4, IPv6 is the future of internet addressing. So, why the need for IPv6? Well, the current IPv4 system has a limit of about 4 billion addresses. Considering the number of devices we have today, that's a rather limited pool. In fact, we've already exhausted the IPv4 addresses. That's where IPv6, with its mind-boggling capacity of around 340 undecillion addresses, comes to the rescue. Yes, that's a number with 36 zeros. With IPv6, we're not running out of addresses anytime soon. But IPv6 isn't just about more addresses, it's also about structure. An IPv6 address is 128 bits long, divided into 8 groups of 16 bits each. Each group is expressed as 4 hexadecimal digits. It's quite a mouthful compared to the 32-bit structure of IPv4, but it opens up a whole new world of possibilities. One of the great things about IPv6 is its improved features over IPv4. It simplifies packet headers for routing efficiency. It also integrates encryption and authentication capabilities, enhancing security. And let's not forget about its support for new services and innovations thanks to its virtually unlimited address space. To put it simply, IPv6 is like the city planner of the future. It's laying down the infrastructure for an ever-expanding digital world, ensuring every device has its own unique address. It's making the internet not just bigger, but also better, more efficient, and safer. IPv6 is not just about offering more addresses, but it's also about making the internet more efficient and safer. Now that you understand what IPv6 addressing is, let's delve into how to configure it. First off, let's start with the basics. To configure IPv6 addressing, you need to access the command line interface of your network device, be it a router, switch, or a server. But remember, each device might have a slightly different process, but the general idea remains the same. Step 1. Enable IPv6 routing. It's quite simple, really. Just type in IPv6 unicast routing in the global configuration mode. This command switches on IPv6 routing on your device. Without this, your device won't be able to route IPv6 packets, even if you've configured IPv6 addresses on your interfaces. Next, you move to the specific interface you want to configure. Type interface, followed by the interface's name. Once you're there, it's time to assign the IPv6 address. The command for this is IPv6 address, followed by the IPv6 address and prefix length. The prefix length is crucial as it determines the network and host portion of the address. Don't forget to activate the interface by typing no shutdown. This command brings the interface up and makes it ready to transmit and receive packets. Now, let's talk about potential issues. One common problem is forgetting to enable IPv6 routing. If you don't enable it, your device simply won't route IPv6 packets. Another issue is incorrectly typing the IPv6 address or prefix length. Mistakes here could lead to network miscommunication or even complete isolation. So, always double-check your entries. Also, keep in mind that IPv6 uses hexadecimal characters, so be careful not to mix up numbers and letters. And remember, the characters are case-insensitive, so you can use either upper or lowercase. Finally, after configuring the IPv6 address, always verify your configuration. You can do this by using the Show IPv6 Interface command. This will display the IPv6 address you've assigned, the link local address, and the state of the interface. And that's how you configure IPv6 addressing. Remember, practice makes perfect. It's been quite a journey exploring virtualization and IPv6 addressing, hasn't it? Let's recap what we've learned. We kicked off our exploration with the fundamentals of virtualization. We learned that virtualization is a technology that allows us to create multiple simulated environments or dedicated resources from a single physical hardware system. It's like having several computers working independently within one physical machine. Quite the space saver, isn't it? In our journey, we also discovered the different types of virtualization. We have server virtualization, which allows a physical server to be partitioned into multiple smaller virtual servers. Then we have network virtualization, splitting available bandwidth into independent channels that can be assigned to specific servers or devices. Lastly, we talked about storage virtualization, which pools physical storage from multiple network storage devices into a single storage device managed from a central console. We then shifted gears to IPv6 addressing. We learned that IPv6 is the latest version of the Internet Protocol, which identifies devices across the Internet so they can be located. We also discovered that its structure is quite different from its predecessor, IPv4. IPv6 addresses are 128 bits long and written as 8 groups of 4 hexadecimal digits, a significant increase from the 32-bit length of IPv4 addresses. Finally, we dove into configuring IPv6 addressing. We learned that it involves assigning an IP address to a network interface, enabling the interface to communicate with other devices on the network. We also touched on the concept of prefixes and how they play a crucial role in IPv6 configuration. As we close this episode, it's important to remember that both virtualization and IPv6 addressing are not just buzzwords. They are vital technologies that are shaping the future of networking. The more we understand them, the better we can adapt and excel in this rapidly evolving field. It's important to remember that both virtualization and IPv6 addressing are vital for the future of networking. So keep exploring, keep learning, and stay tuned for our next episode.